testing, Java, and we're looking at Chapter 8. We'll look at the UML for our program coding. We're now dealing with classes again and our driver program. In our program 8.4 assignment, we're asked to create a class rectangle with attributes length and width. Each of these defaults to 1. So we'll have to arrange for that to happen on a construction of a new rectangle object. Provide methods that create the rectangle's perimeter and area. So we'll have methods that we can call to create or to calculate and return the perimeter, and a method to calculate and return the area. It has a set and get method for the length and the width. The set methods should verify that the length and width are floating point numbers larger than 0.0 and less than 20. So we've set some restrictions on the length. We don't want a negative length, obviously, and we are only testing. We don't want to have our numbers expand too large in our testing environment. And then write a program to test class rectangle, which will be likely our rectangle test.java program that is the driver and instantiates the rectangle objects. So we're thinking now back to Chapter 3 when we early on introduced our first class objects and our driver programs to instantiate class objects and get, set, get width, set length. So we were interacting with our object and its instance variables. We constructed our UML in Chapter 3. That's kind of our pseudocode. So I've sketched a UML along with kind of sketching the pseudocode, the pseudo logic of our rectangle object and what that object should be able to do for itself. So I'm going to name my class rectangle, and this object will have a private instance variable by the name of length, and it's of type double, and it will have a private instance variable named width, and it's of type double. So this rectangle object will know its own length and its own width. We were told in our directions that we should initialize our length and width instance variables to 1. So our constructor is a default constructor, public rectangle with no parameters. And we're using our keyword this. This replies to this class, which is the class rectangle, and its instance variables as they're named length and width. So length is going to be assigned 1 and width is going to be assigned 1 through the default constructor using the this class. And this class is the rectangle class. So on instantiation with a default constructor, length and width are both set equal to 1. We have a constructor public rectangle that accepts a double length and a double width variable. Locally, the variable name is the width and the length. Those are local variables known within the duration of this block of code. So we can pass in a length and a width, the double value, and then we can call the set length method of this class rectangle and pass the length value. So the set length method is, it's a public void set length. The parameter is a double. It's receiving the length, and we're passing the length value. The length will be assigned that value locally within the set length method. We want to validate and set length. So we're going to validate, again, our direction stated that we want to protect the length It needs to test greater than 0.0 and, that's your ampersand, ampersand. We're using the and logical operator. The length has to be less than 20. Now, if that's true, then length, which is the instance variable of this class, the instance variable will be assigned or reassigned the length that was passed to this setLength method. Else, we're going to throw an illegal argument exception and prompt the users with some statement that the length was out of range. And we're at the end of setLength. Back to the main calling environment, the next statement is setWidth, and that method is going to be passed the width that was passed to the rectangle constructor. So we're passing a value. We're going to pass that value to the setWidth method. It's a public void setWidth method where it accepts a double value. We're passing the width. We're going to validate and set the width. Similar to the coding we did for setLength. We also want to create some activity, some processing, some calculations that this class can do and return regarding itself. So we're going to create a public void get length and get width, and we're familiar with how to set those up coding-wise from Chapter 3. Now we'd like to create a method that can calculate this rectangle's perimeter. This will be a public method. It's going to return double the parameter's value once calculated. So get parameter, no parameters are sent to this method. We're going to return a double 2 times this rectangle's length plus 2 times this rectangle's instance variable width. Remember, the perimeter is 2 times the length plus 2 times the width. It's a little length there for you, it is plus. The perimeter is calculated as 2 times the length plus 2 times the width. We're going to return that as a double to the calling environment. And we're at the end of calculating the perimeter in the method get perimeter. We also want this rectangle to be able to calculate its own area. So we're going to create a method for it to do that action of calculating an area. That's a public. It's going to return a double, get area with no parameters. We're going to return, well, to calculate the area of a rectangle, it's the length times the width. So this method is using the instance variable length times the instance variable width and calculating the area of this rectangle. And we're going to return that to the calling environment as a double. Now we'd like to have some type of output, and we'd like to be able to design and format that output. So we're going to create a public string. A string is going to be returned to the calling environment, toString with no parameters set. And we can design any type of layout with the particular information that we might need, like length. This is a title, so it'd be a string value with the calculated current length of this object's instance variable. Width would be a string, and we're formatting to output the width as it's assigned as the instance variable current value for this object. String perimeter, and then we want to output the calculated perimeter value. And area, we have a nice neat report with a string area and calculate, print the calculated area's value. So that's the UML and the logic for this program. In your Chapter 8 lesson plan, I've shared with you the solution for the rectangle test.java. So that's actually our driver program. So we'll have our main method within the rectangle test.java, and it will be interacting with the rectangle class. So you can use this then for your rectangle test.java code. We need to import java.util.scanner. We will be using and accepting input from the keyboard. Public class rectangle test is our class name as well as the file name. Remember, we use upper lowercase as significant. Public static void main, this is the main driver of the program, so we'll start execution with the main method. Scanner input, new scanner input from the system input, which is your keyboard. Rectangle object, we're calling with a variable name rectangle. It's equal to a new rectangle object. So we'll call the default constructor in our rectangle class, which you're going to write and design and code. Int choice. I'm trying to give you an example of a menu-driven program. It's not ideal. When we get our output, you'll see and maybe be unhappy with the output, but it gives you a chance to experiment with a menu-driven program. So I'm declaring choice as an integer, and it's equal to get menu choice. So we're calling a method. There's no parameters being set. So we have to go to that method. Now this is a private static. It's going to return an integer, get menu choice. And beginning end, we're going to get some input from the keyboard. Number 1, first, please enter the length. So we'll prompt it to enter the length. Number 2, next, please enter the width. Number 3, exit and print the perimeter and the area. And output, what is your choice? So this will print the menu on the keyboard, and when the user taps 1, 2, or 3, it will return that input, which is the next integer typed from the keyboard. So our get menu choice is going to return as an integer either 1, 2, or 3, which is the choice of the user. So I'm going to return 1. I'm going to tap 1. My choice is 1. So it'll return the next integer value of 1, and we're at the end of get menu choice. Going back to the main calling environment, I typed 1. So choice is assigned 1. While choice is not equal to 3, well, it's not. It's equal to 1. So we will move into the while driver, and we're in a try catch block. A try catch block. Here's our try and our catch. So we're going to try this code, and if the code is successful, we won't process the catch and continue with the next line of code. If the try is unsuccessful, we'll process the catch block, and system out.println will indicate to the user length and width must be 0.0 through 20.0, and hopefully that prompts the user to enter valid input. If the try block is successful, the user will have typed in case 1, case 2, or and case 1 and case 2, both are integers, will successfully enter 1 or 2. The choice will be assigned from the get menu choice. So choice is accepted as 1 or 2 as valid input. So if I type 1, I get system.out.print enter the length. So I'm going to enter the length, and I can enter the length as 5. If I enter length as 5, in a case situation, that's the end of the switch. So it was successful. I bypassed the catch block. And now at the end of the while, I'm going to choose my next menu choice. So I'm calling the get method menu choice, and I'm going to print, maybe type out from my menu choice, maybe my next option is 2. So I'll enter 2. Choice is now equal to 2. Two is not equal to 3, so we'll continue with the while block and enter 2. It's a successful try, so choice is equal to, if I type 3 with my menu prompt, I'm going to be exiting and printing the perimeter and the area. If I type 3, my while driver will test while choice is not equal to 3. It is equal to 3, so that triggers exiting of the while loop. So I'm at the end while. System.out a new line, system.println, rectangle.toString. So I'm calling the rectangle toString method, and the rectangle toString method is something that we have to design yet. We know that we want to output information about this object, this rectangular object's instance variables, length and width, and we want to output the calculated perimeter, we want to output the calculated area neatly, and kind of a little summary report before we end the main program. So let's take a look at the program itself for our rectangle. This is class rectangle, so my file name is rectangle.java. It's a public class rectangle. I'm initializing and instantiating a private length variable as a double, and a private width variable as a double, as instance variables for this rectangle. So this rectangle knows its own length and its own width. We have the public rectangle constructor, which we were told in our directions for this program that we want to set this object's instance variables length and width to 1. So that's what the default constructor accomplishes. We also have a constructor designed, a public rectangle constructor that will construct a rectangle object with a passed double by the name of length, and a passed to this constructor a double by the name of width. Now, if we're passing the length and the width into the constructor, because at runtime we know the length of the rectangle and the width of the rectangle, we want to make sure that we test or validate the length as less than or equal to 0, or remember your vertical bar vertical is or length is greater than or equal to 20. So if length is less than or equal to 0, that would be invalid. Or if length is greater than or equal to 20, that's outside of our allowable range. We want to throw a new illegal argument exception with a string length out of range. We're going to test for validity on the width. If the width is less than or equal to 0, or the width is greater than or equal to 20, we're out of range for this program. So we're going to throw an illegal argument for that. This should be width out of range. And of course, you can be a little more thorough on the prompts to the user. Otherwise, we've tested for validity of the length, we've tested for validity of the width, so we can set this object's instance variable length. This dot length we can set equal to the length that's passed to the rectangle constructor and has passed the validity test. We can also set this dot width instance variable for this object equal to width, which was passed to the constructor and has passed the width validity check. We want to be able to set the width, so we're going to design our set length and our set width methods to set and validate the length. Public void set length. It's going to receive a double by the name of length. Length here is local to this method. If length is less than or equal to 0 or greater than or equal to 20, we're going to throw an exception. Otherwise, this dot length is equal to length. So we're reassigning the instance variable length equal to the length that was passed to the set length method. And the same for set width. We're constructing a method that will allow this object to set its own width. Public void set width. Set width is receiving a double by the name of width. Width is local to this method. We're testing for validity. If width is less than or equal to 0 or width is greater than or equal to 20, throw a new illegal argument exception. Set width again is out of range, and again you can do a better job of prompting the user than I did. In the set width method, if width passed to the method passes validity, then this object's instance variable width will be assigned to width. We want to be able to get the length and get the width. This object should be able to get its own length and get its own width. So we're going to write a method that allows that action to occur. Public double get length, no parameters are set. Return length, and length is the instance variable for this rectangle, and it's of type double. Get the value of the width. We need to have a method that will allow us to get the width of this rectangle object. So public double is returned, get width. We're going to return this object's instance variable width as a double. Now this object is supposed to be able to calculate its perimeter. So we need to design that action using a method. Public double get perimeter, no parameters are sent. To calculate the perimeter, we need to return as a double 2 times get the length. So we'll get the current instance variable's length plus 2 times get the width, which will return to us the current instance variable's width value of this object. We'll calculate that expression and return it as a double to the calling environment. This object was also supposed to be able to calculate its own area, which is an action that this object should be programmed, coded. It should know how to do. So we're going to code our public double get area method. The method is an action that can be accomplished through code. So we're going to return get the length. So we're going to call the method get length, which returns the current instant variable value of this object's length, times get the width. We're calling the method. Get width will return as a double the current width instance variable value. We're going to return that expression, which is multiplication, as a double to the calling environment. And we want to be able to output a nice, well-formatted, maybe little summary report. So we can call public string. We want to return a string to the calling environment, toString method. No parameters are set. Now we're going to return as a string, well-formatted, string.format. And we have our format. We're going to return a string. Well, the first string is a length, colon. We're going to return a floating point value, which our get length is going to return a double, a new line, a string, which is width with the colon following it. We have get width, which returns a double, so we're going to output a floating value with a new line. And then we're going to output a string parameter with a colon, output a string format value, floating point value, which is get perimeter, it returns a double value, a new line, and another string with a colon, area colon, and one last floating point value, and get area is going to return a double for us. So let's see what happens. At NetBeans, I'm looking at the rectangle test.java file, rectangle test.java, and the name of my class is rectangle test. So that looks good. This is exactly the shared program that I placed in your Unit 8 lesson plan, so you can simply type that in as shared with you, or copy and paste to Notepad and then add as a new file in your project. So let's look at rectangle. Here's our rectangle.java file name and the rectangle class name. This class, rectangle, is being instantiated in current memory with a private double length and a private double width. We have a public constructor rectangle that will initialize this class object's instance variables to 1.0 and 1.0. And remember, we're using floating point or double values here, so you have to type that in with a decimal precision. So now our instance variable for this object length is set equal to 1, and the instance variable width is set equal to 1. So we've initialized the instance variables to valid instantiation or on startup assignment. Here's a constructor where the length and the width are supplied. So your driver program could actually instantiate a rectangle by sending a length of type double and a width of type double. So if that happens, we need to work through our error trapping, where we're testing for validity for the length. We're testing for validity for the width that is being passed to this constructor. If validity checks are passed, then this object's instance variable length can be assigned to length, and this instance variable's width can be assigned to the width that was passed into the constructor and has passed the validity checks. This rectangle object can set its own length with a set length method, where a double length value is passed to the set length. This length variable is then local to this block of code. If length is less than or equal to 0 or length is greater than or equal to 20, then we want to throw our exception. Otherwise, this object's instance variable length can be assigned the length value that was tested and passed into this method. That holds true for the width. Now we also want to be able to get the length, so this rectangle should know how to get its own length. Our public get length method will return a double. So we have the return of the instance variable length. we should be able to get our own width. This rectangle object should be able to return its instance variable width. So we can get and set the length and the width with those actions through code of an action method that accomplishes that task. We also want this object to be able to calculate its own perimeter. So we're going to create a method for the action of calculating this rectangle's perimeter. We want to return a double, and get perimeter has no parameters. Return the expression result of 2 times, we're calling the get length method. The get length method returns a double of this rectangle's instance variable length, plus 2 times get width, which is a method that returns the instance variable's current width value. And we calculate the perimeter of a rectangle as 2 times the length plus 2 times the width. That will be calculated and returned as a double value to the calling environment. This rectangle object should be able to calculate its own area, so we want to write a method that will perform that action. So public get area returns a double, and get area has no parameters. The calling environment calls get area, and it will return as a double get the length, which is the current instance variable object's length, times get width. When we call the get width method, it returns a double of the instant variable's current width value. And then we want to design some method that will allow us to create a summary report. So public string toString, this is a method that all objects inherit. So we can call the toString for this object. And we want to design a nice, neat report as a string to be returned to the calling environment. And this is a string.format, and we've used our formatted string options to print out a string and a floating point value, a string and a floating point value, a string and a floating point value, and a string and a floating point value, ending up with outputting the current length, width, perimeter, and area of this rectangle. Now, you can design a nice, neat report and actually design your own formatted string. If you care to design a fancier report, that would be just fine for this output purpose. So let's try running the program. All right, remember that the rectangle test is the driver, and in the rectangle test we've arranged for a menu to be displayed to our user. And the menu says set the length, set the width, exit, and make your choice with the integer options from your menu selection. Not well prompted to the user, but you could precede that with a paragraph right up here, a running paragraph of directions as to how to use this menu. So I'm going to choose 1, which is set the length. Enter the length, and I'm going to enter 5. And it immediately calculates with choice 1, I entered the length of 5. The length is 5 in my summary report. The width is 1 because that's still the instance variable initialization to 1 by the default constructor. That has not been changed. The perimeter then would be 2 times 5 is 10 plus 2 times 1 is 2 for 12. And the area would be 5 times 1, the length times the width, which is 5. Well, now I'm going to go ahead and use my menu, which appears for me, and I'm going to select 2 as my choice from the menu. And ask me to enter the width. I'm going to enter 3. Now, a nice, neat report is produced I did not change the length. The length is still 5. I did change the width from its initialization value of 1 to 3, so that was reassigned. So the instance variables of the rectangle now are width is 3 and length is 5. The perimeter is recalculated. The perimeter is 2 times the length. The length is 5. The width is 3, so 2 times 5 is 10, plus 2 times 3 is 6 for 16 as a perimeter. And the area is calculated with a length of 5 and a width of 3. The area is calculated as length times width, so 5 times 3 is 15. And we've allowed this to print out in a floating point precision, so no control over round off to a certain decimal place or precision to a accuracy to a certain placeholder. You could certainly experiment with that in your output two-string report string format as well. Well, now I should test my program a bit further. Let's try, I want to set the length again, and I'm going to set the length to -10. And here's your exception being thrown that the length and the width must be between 0.0 and 20. And of course, you could be more explicit to your user with that exception string comment. My menu returns. No output is calculated with that invalid input. The menu returns, and I'm going to type 3 as my choice to exit, and the program exits successfully. All right, so we are working on our last program assignment, which is Prog 8.4. I think in your lesson plan 8 directions. So we're to create the class rectangle Java given the application rectangle test.java, which has the main method and becomes the driver for this program, driving, interacting with the class rectangle. Now, I hope you've studied and reviewed all of the videos requested of you in this chapter before you listen to my explanation. You might want to go back to your notes in chapter 3 where we introduced first class objects, and maybe your notes there. And then as you experiment and begin to work with the rectangle class in your program 8.4 for Prog 8 assignment for chapter 8. And that will conclude the assignments for Java 1. There is no final exam. As you open the last lesson plan, you'll learn that there is no final exam. Actually, as we move through these 8 chapters, you're continually reviewing day 1 information. So in order to be successful for program 8, you had to have success with program 7 and program 6 and so on. So we've been building on our information and continually testing in assessment with your exercises and your in-depth programming activities. So thank you very much. I hope you enjoyed the class, and look forward to meeting you again in another programming class as you begin and continue your computer science career. Thank you.